My name is Bandar. This is a multi-agent ticket resolution system for an e-commerce support platform. It automates ticket triage, policy retrieval, escalation decision making, and customer response stuff. So we are basically using Graph PY and LangGraph orchestrators for this, and this is our main Python file. And let's move on to the demo. So first, I need to add the name, and then I will add the ticket itself, and then it will go through the workflow. First, agent 1, the classification, and then it will move on to the agent 2 retrieval. So as you can see, after retrieval, it will go to the agent 3 decision agent, escalation decision agent, and then the final agent drafting response drafting agent. And you can see the final response like this, and that's basically about the system. And each member will describe their contributions.
Hi, in this demo, I will show the agent 1, which is the Indian classification agent. This agent takes a customer support ticket and identifies 4 things: the category, the agency, the sentiment, and missing information. My agent is a ticket classifier agent, and custom tool is a ticket classifier tool. Now I go into the run the agent. Here I enter the sample support ticket. Llama 3.2 is processing the request locally, so it makes take a few seconds. Now we can see the result generated by agent 1. The category is identified as shipping issues. The urgency level is shown medium. The sentiment replaces how the customer feels. And if any important details are missing, they are listed under the missing information. This result is based on the structured system prompt. This session shows the audit logging for the agent 1. Every ticket classification is written to classification audit log. So we can track what the model decided and when. Now I'll show the automated evolution part. I used an approach called LLM as agent. That means I use a second separate Llama 3.2 model as an independent evaluator. It takes the 3 things: the original ticket, the expected result, and my agent output. Then it checks whether the result is correct and safe. As you can see, all 8 test cases pass successfully. So that's how the agent 1 works. It classifies customer ticket in the structured plan consistently way using the Llama 3.2. Thank you.
I'm Darshan. My component is knowledge retrieval agent. This is the knowledge retrieval agent. It finds grounded policy evidence for a classified ticket and looks the retrieval for auditing. So here's the implementation of knowledge retrieval agent. And the tool I used is FAQ search. It reads category and ticket text from support state, such as policies.json, using a deterministic ranking, and returns both legacy policy images and policy images details. The LLM is used only to summarize retrieved text, not to invent policies. So this will be the state of knowledge retrieval agent 2. And when we look at a quick demo, when we execute the main.py, agent 1 executes first, and here it gets the knowledge retrieval agent, it gets output of agent 1, and first of all it goes to the policies, and if it finds the thing, it extracts the output and sends it to LLM, and the output will be forwarded to agent 3. And the audit log can be found in retrieval audit log JSON, and also we can find the testing code in test folder. Just ensure deterministic ranking and safe fallbacks. We mock the LLM in test knowledge retrieval to verify structured output and fallback behavior. And we can execute the test file using PyTest. And this will be the demo test file. And yeah, to pass. Thank you.
I'm Bandar, and my contribution is agent 3, the escalation decision agent. Its task is to make the final routing decision in a safe and policy-based way. It first uses business rules, then LLM validations to catch edge cases and avoid unsafe approvals. The agent takes inputs from the shared state, including the ticket ID, customer name, category, urgency, statement, sentiment, and missing information and policy matches. And using the information, it decides whether the case should be approved, escalated, rejected, or sent back for more information. The main tool behind this is the escalation rules engine. It checks customer history, looks for repeats and complaints for fraud flags, and applies killer routes and saves the decision to an audit log for traceability. After that, the Ollama LLM validates the results using a strict JSON response format. The output includes the final decision and the escalation team if needed, and the next steps. The test confirms that it compares correctly across damaged items, missing evidence, billing issues, and abusive language, as you can see in this output.
Agent 4 is the final step in the support workflow. It transforms the escalation decision into a professional custom-friendly response. It reads the ticket context and decision from the shared test state, then draft and returns the final custom message. So input from the state is ticket ID, customer name, decision, escalate to which team route to next steps, policy matches from which are taken from agent 3. So response template builder is the tool that we're using. It creates a structure-based response using decision and next steps. Ollama LLM refines the template into a polished, empathetic message process. So the whole process of this component is extract decision, policy summary, and next steps from the state. And then build a template response using the response template tool. Send the template to Ollama with the system prompt, and validate the response for bad addresses, such as we guarantee internal node, and returns the safe final response. And the output of this state is, as you can see, this drafted response. So the key feature of this component is enforces safety by rejecting customer responses with banned phrases and falling back to template if the LLM output is unsafe. So these are the test cases, and all of them have been passed. And this is the total output of the component.